Way back in 2003, scientists at Duke University trained a monkey to use a robotic arm with a brain-computer interface. They implanted an electrode array that could record the activity of hundreds of individual neurons in the monkey's brain. Researcher Miguel Nicolelis talked about it in his 2013 TED Talk. They called the signal here a brainstorm, and they went about figuring out how to decode it. So they trained a monkey named Aurora with a brain-computer interface to play a simple game. A dot appeared on the screen, and Aurora controlled a cursor over to the dot with a joystick. Whenever the cursor touched the dot, Aurora got a little drop of orange juice, and the team got some data about what the brain was doing when Aurora moved her arm. She did something like 1,000 trials a day with nearly a 97% success rate, and all the while they were sending the signal to a robotic arm that was learning to reproduce Aurora's movements. Eventually, she figured out how to move the cursor with the robotic arm. Then she figured out how to move the cursor with the robotic arm without moving her own physical arm. It was basically like she had acquired a new arm, an extension of her body. The same team years later had a monkey running on a treadmill with a brain-computer interface. And they sent those signals to a team in Kyoto that had a robotic humanoid that would walk using the information in real time. The team in Kyoto sent live video all the way back to Duke so the monkey could see it. What's crazy is it takes about a half a second for a signal to get sent from the brain to the arms or legs of an animal. And the round trip of the internet signal from Duke to Kyoto back to Duke took 20 milliseconds less than it takes for the neurological signal to get down to the animal's extremities. This all makes me believe that one day I'll have some accessory Dr. Octopus arms and I'll do a bunch of cool stuff with them. The truly exciting and less selfish applications are going to be assistive technology for people with disabilities. Like in 2019, a paralyzed Frenchman was able to walk using a mind-controlled exoskeleton. Future versions may even be able to electrically stimulate a person's own muscles. And researchers from the University of California, San Francisco have used brain-computer interfaces to help people with anarthria. Anarthria is a motor speech disorder that makes it impossible for people to produce understandable speech even though they can understand speech. In 2019, they were able to use deep learning to synthesize speech. In 2021, they were able to decode and synthesize the speech of an anarthritic patient who had been unable to speak for 15 years.